Hello and welcome back. In this video, we're going to find the integral of the secant function. And this is a very tricky problem because when you first look at it, you might say, oh, I can just say it's this. And like, no, it's actually not, because if it was secant squared, this problem would be a couple seconds long. But because it's secant to the first power, it's not recognized as anybody's derivative from the first part of the course. So instead, we're going to do a very, very clever trick. We're going to take our integral and multiply by a suspicious choice of 1. We're going to multiply by the fraction secant of x plus tangent of x over the same exact thing, secant of x plus the tangent of x. And of course, we're still integrating with respect to x. So here you may say to yourself, well, it looks like we sure made things worse than we needed to. But by multiplying by this clever choice of 1, we now end up with an integral that we're going to recognize in a few minutes. So when I distribute and multiply, I'm going to have the secant squared of x plus the secant of x times the tangent of x, all divided by the sum secant of x plus the tangent of x respect to x. So now you will notice that we're exactly where we want to be. We have a function in our denominator which has its derivative upstairs in the numerator. So we're going to let u represent that sum. We're going to let u equal the secant of x plus the tangent of x. And when we find the derivative du dx, we're going to have the secant of x tangent of x plus the secant squared of x. So dx is just du divided by secant of x tangent of x plus secant squared of x, which we recognize as our numerator. So this is now the integral with a secant squared of x plus secant of x tangent of x over top of u times du over the secant of x tangent of x. Yeah, we need to write more space in here. So let's back this up and erase this so it's a little easier to follow. So let's back up to this equal sign, now taking us down to here. So this is going to be equal to, again, we've got our secant of x tangent of x plus our tangent squared of x up there. We've got our u down here, and now over here we've got our du divided by our secant of x tangent of x plus the secant squared of x. And would you look at that? This cancels with that, and we are left with just the integral of 1 over u du, which is very easy to do. We recognize that as the natural log of the absolute value of u plus c. So last step, replace that u with the secant of x plus the tangent of x in absolute values plus c. And that right there is the integral of the secant function. And if you wanted to check this, you could just take the derivative and it will simplify completely down to just plain secant of x. So again, we have to multiply by a very clever choice of 1 to find this integral, but it can't be done. If you have the cosecant of x, you actually take the sum cosecant plus cotangent to do the same exact job. So these problems are very closely related by that multiplying by a clever choice of 1.